Hi guys, tonight we're going to explore one of the most terrifying scenarios imaginable. What would happen if the moon suddenly started falling toward Earth? We're talking about a cosmic collision that would unleash forces beyond anything in human history, reshaping our entire planet in a matter of hours. If you enjoy these intense sleep stories that explore catastrophic what-if scenarios, hit that like button and subscribe for more. And drop a comment letting me know what time it is where you are and where you're listening from. I love hearing from all you night owls around the world. Alright, let's begin. The morning sky erupts in an impossible sight as our familiar silver companion, the moon, begins its final catastrophic journey toward Earth. What was once a gentle celestial dance spanning 4.5 billion years transforms into a cosmic collision course that will reshape everything we know about our planet and our existence upon it. The moon, with its mass of 73 trillion kilograms, stretches approximately 3,476 kilometers across its widest point. To put this in perspective, you could fit about 4 moons side by side across the continental United States. This massive celestial body, currently sitting at an average distance of 384,400 kilometers from Earth, suddenly finds itself pulled inexorably toward our world by forces beyond comprehension. As astronomers worldwide detect this impossible scenario unfolding, the first question becomes not if, but when. The moon's orbital velocity normally maintains it at a stable 1700 meters per second, but now, as gravitational forces overwhelm its orbital momentum, it begins accelerating toward Earth at an ever-increasing rate. The journey that light completes in just over 1 second will now take the moon approximately 64 hours to traverse, but these will be the most transformative hours in Earth's 4.5 billion year history. During the first 12 hours, observers on Earth witness a phenomenon unlike anything in recorded human history. The moon, typically appearing as a disk roughly half a degree wide in our sky, begins to visibly grow larger with each passing hour. Amateur astronomers with modest telescopes can now discern individual craters and mountain ranges with unprecedented clarity. The familiar features that have inspired poets and lovers for millennia, the Sea of Tranquility, the brilliant ray system surrounding Copernicus crater, and the stark shadows cast by the Apennine Mountains, all become visible to the naked eye. But this cosmic spectacle comes with immediate and devastating consequences for life on Earth. The moon's gravitational influence, which normally creates tides averaging about 2 meters in height across Earth's oceans, begins to intensify dramatically. As the moon draws closer, cutting the distance from 384,000 kilometers to 200,000 kilometers in the first day, tidal forces increase by a factor of 7. Coastal cities from New York to Tokyo experience unprecedented flooding as tides surge to heights of 14 meters above normal sea level. The Bay of Fundy in Nova Scotia, already famous for having the world's highest tides at 16 meters, now witnesses walls of water reaching heights of over 100 meters. The English Channel becomes a churning maelstrom as tidal forces create currents moving at speeds exceeding 50 kilometers per hour. Venice, built on a foundation of more than 118 small islands, disappears entirely beneath the surge. The city's famous St. Mark's Square, normally sitting just 1 meter above sea level, lies buried under 14 meters of turbulent seawater. As the moon continues its approach, now visible as a disk twice its normal size, Earth's crust itself begins to respond to the intensifying gravitational stress. The solid ground beneath our feet, seemingly immutable, starts to bulge and flex like a basketball being squeezed. This solid Earth tide, normally imperceptible at just 30 centimeters of vertical movement, now reaches amplitudes of several meters. Ancient fault lines, dormant for millions of years, suddenly rupture under the unprecedented stress. The ring of fire around the Pacific Ocean explodes into activity as the moon's approach triggers every major fault system simultaneously. The San Andreas Fault in California, capable of generating magnitude 8 earthquakes under normal circumstances, now produces a continuous series of magnitude 9 tremors. Los Angeles, built atop a complex network of fault systems, experiences ground acceleration forces exceeding 2 times the force of gravity. Skyscrapers designed to withstand typical seismic activity, including the earthquake-resistant structures reaching heights of 335 meters, like the Wilshire Grand Center, simply cannot cope with this unprecedented assault. Across the Pacific, Japan's sophisticated earthquake preparedness systems, designed to handle a magnitude 9 earthquake that struck in 2000 and 2011, prove completely inadequate. The country's 27,000 kilometers of seawalls and tsunami barriers crumble as the combination of massive tides and continuous seismic activity creates waves reaching heights of 50 meters above normal high tide levels. Mount Fuji, dormant for over 3 centuries, awakens with violent eruptions as magma chambers throughout the Japanese archipelago destabilize under the moon's gravitational torture. The Yellowstone caldera in Wyoming, sitting atop a magma chamber containing approximately 15,000 cubic kilometers of molten rock, reaches a critical threshold. The supervolcano, which has remained dormant for roughly 70,000 years, finally succumbs to the intense gravitational stress. The eruption that follows releases energy equivalent to approximately 1,000 times that of the most powerful nuclear weapon ever detonated, the Soviet Union's 50-megaton Tsar bomber. As the moon draws to within 100,000 kilometers of Earth, roughly 1/4 of its original distance, its gravitational influence creates tidal bulges in Earth's oceans, reaching heights of over 200 meters. The Mediterranean Sea, normally containing approximately 4 million cubic kilometers of water, becomes completely unrecognizable as massive waves surge back and forth between Europe and Africa. The Strait of Gibraltar, just 14 kilometers wide at its narrowest point, cannot accommodate the enormous volumes of water attempting to flow through it, creating a bottleneck that turns the western Mediterranean into a temporary inland sea elevated dozens of meters above its normal level. But perhaps nowhere are the effects more dramatic than along Earth's equatorial regions, where the moon's gravitational pull combines with Earth's own rotational forces to create a perfect storm of destruction. The Amazon River, normally carrying approximately 200,000 cubic meters of water per second toward the Atlantic Ocean, reverses its flow entirely as massive tidal bores surge inland. The river's mouth, typically 160 kilometers wide, becomes a funnel for walls of water reaching heights of 150 meters above normal river level. Manaus, Brazil, located over 1,000 kilometers inland from the Amazon's mouth, and normally sitting at an elevation of 92 meters above sea level, finds itself inundated by the largest river reversal in Earth's history. The city's population of over 2 million people has less than 6 hours to evacuate as the tidal surge travels upstream at speeds approaching 100 kilometers per hour. The Amazon rainforest, containing approximately 10% of Earth's biodiversity across its 5.5 million square kilometers, becomes a temporary inland sea as the reversed river flow spreads across an area the size of Western Europe. Meanwhile, the moon itself, now appearing in Earth's sky as a disk 4 times larger than normal, begins to show signs of its own structural stress. The Roche limit, the distance at which tidal forces from a massive body overcome the gravitational binding of a smaller orbiting object, lies at approximately 18,400 kilometers from Earth's center for rocky bodies like the Moon. As our natural satellite approaches this critical threshold, the gravitational gradient across its 3,476 kilometer diameter becomes increasingly severe. The side of the Moon facing Earth experiences gravitational acceleration roughly 7% stronger than the side facing away. This difference, multiplied across the Moon's enormous mass, creates internal stresses exceeding the tensile strength of lunar rock. The first visible signs appear as massive cracks spreading across the lunar surface, particularly through the ancient impact basins like Mare Imbrium and Mare Serenitatis. These features, formed by asteroid impact billions of years ago, represent zones of weakness where the Moon's structure first begins to yield to Earth's inexorable gravitational pull. As fragments begin breaking away from the Moon's leading hemisphere, they follow ballistic trajectories toward Earth at velocities exceeding 11 kilometers per second. The first impacts occur in the Pacific Ocean, where lunar boulders the size of city blocks strike with energies equivalent to multiple nuclear weapons. Each impact generates tsunamis that dwarf even the massive tidal surges already devastating coastlines worldwide. A single lunar fragment measuring just 100 meters in diameter, traveling at 11 kilometers per second, carries kinetic energy equivalent to approximately 65 megatons of TNT. When such a fragment strikes the Pacific Ocean approximately 2,000 kilometers west of California, it vaporizes millions of tons of seawater instantly, creating a steam explosion visible from space. The resulting tsunami, generated by both the initial impact and the collapse of the massive steam bubble, races outward at speeds approaching the speed of sound in water, roughly 1,500 meters per second. Hawaii, sitting in the middle of the Pacific Ocean, experiences the full fury of multiple impact-generated tsunamis converging from different directions. Honolulu, built at sea level across the southern shore of Oahu, disappears beneath waves reaching heights of 300 meters above normal sea level. Mauna Kea, the island's highest peak at 4,207 meters above sea level, becomes a temperate island as the surrounding landscape vanishes beneath the turbulent waters. But these localized impacts pale in comparison to the global catastrophe unfolding as the Moon approaches to within 50,000 kilometers of Earth. At this distance, the Moon's apparent size in the sky equals roughly 8 times its familiar dimensions, appearing as a massive cracked sphere dominating nearly 20 degrees of the celestial dome. The sight is simultaneously awe-inspiring and terrifying, as billions of people worldwide witness their planet's companion slowly disintegrating against the backdrop of a sky that no longer resembles anything in human experience. Earth's atmosphere itself begins responding to the Moon's proximity in unprecedented ways. The Moon's gravitational field creates atmospheric tides, normally imperceptible variations in air pressure that cycle with the lunar month. Now, as the Moon draws near, these atmospheric tides intensify to create pressure variations exceeding 50% above and below normal atmospheric pressure. The result resembles a global-scale version of the pressure changes experienced during severe hurricanes, but affecting the entire planet simultaneously. Weather patterns across Earth become completely chaotic as the varying atmospheric pressure disrupts normal circulation patterns. The jet streams, normally flowing at altitudes around 10,000 meters at speeds of 50 to 100 kilometers per hour, accelerate to speeds exceeding 300 kilometers per hour while following completely unpredictable paths. Hurricanes form spontaneously over every ocean, fed by the enormous energy released by the churning waters below and the chaotic pressure systems above. The Antarctic ice sheet, containing approximately 26.5 million cubic kilometers of ice, representing roughly 70% of Earth's fresh water, begins responding to the enormous tidal forces now affecting the solid Earth beneath it. As the bedrock underneath the ice sheet flexes vertically by tens of meters with each tidal cycle, massive crevasses open throughout the ice. The Ross Ice Shelf, roughly the size of France at 487,000 square kilometers, begins carving icebergs the size of small countries. Simultaneously, the Greenland ice sheet, containing approximately 2.5 million cubic kilometers of ice, experiences similar destabilization. The combination of massive tidal flexing in the underlying bedrock and the increasingly chaotic weather patterns creates conditions unlike anything seen in Earth's recent geological history. Glacial valleys that have remained frozen for millions of years suddenly experience flash flooding as ancient ice melts under the mechanical stress of the Moon's gravitational torture. As the Moon continues its death spiral, approaching to within 25,000 kilometers of Earth, it finally crosses the Roche limit for rocky bodies. The gravitational gradient across the Moon's diameter now exceeds the gravitational binding force holding the lunar material together. What happens next unfolds over the course of several hours, creating a spectacle that would be beautiful if it weren't so utterly catastrophic. The Moon begins breaking apart along the fracture lines that have been developing throughout its approach. The process starts with the lunar surface layers, where the gravitational differential is most pronounced. Massive chunks of lunar regolith, some weighing billions of tons, begin streaming away from the Moon's Earth-facing hemisphere. These fragments, ranging in size from boulders to small mountains, form a growing cloud of debris spreading across millions of cubic kilometers of space. The Mare Tranquillitatis, the Sea of Tranquility where Apollo 11 first landed in 1969, becomes one of the first major lunar features to disintegrate completely. The basaltic rock that formed this ancient lava plain, approximately 3.5 billion years old, crumbles into fragments that stream toward Earth like a cosmic avalanche. Among this debris, preserved in fragments no larger than automobiles, lie the remains of human achievement. The lunar module descent stage, the American flag, and the scientific equipment left behind by Neil Armstrong and Buzz Aldrin. As larger sections of the Moon break away, the remaining lunar core, composed primarily of iron and nickel, with a diameter of approximately 180 kilometers, continues its inexorable approach toward Earth. This remnant, still containing approximately 20% of the Moon's original mass, represents roughly 14 trillion kilograms of material, now following a collision course with our planet. The debris cloud preceding the lunar core creates a bombardment unlike anything in Earth's history since the late heavy bombardment period, approximately 4 billion years ago. Fragments ranging from pebble-sized particles to chunks the size of Mount Everest rain down across Earth's surface at velocities exceeding 11 kilometers per second. The smaller particles burn up in Earth's atmosphere, creating meteor displays visible even in broad daylight. But the larger fragments, some weighing millions of tons, penetrate through the atmosphere to impact the surface with devastating effect. A lunar fragment measuring 5 kilometers in diameter, approximately the size of Manhattan, strikes the Atlantic Ocean midway between Europe and North America. The impact energy, equivalent to approximately 100 million megatons of TNT, instantly vaporizes a volume of seawater equal to Lake Superior. The resulting crater, carved into the ocean floor at a depth of 4,000 meters, measures roughly 50 kilometers across and creates a circular shockwave that travels outward at supersonic speeds. The tsunami generated by this impact dwarfs all previous waves in Earth's recorded history. Moving at speeds approaching 700 kilometers per hour, waves reaching heights of 1,000 meters above normal sea level race toward both the European and American continents. London, Paris, and New York City, separated by thousands of kilometers of ocean, all experience the arrival of these mega tsunamis within hours of each other. The eastern seaboard of North America, from Miami to Nova Scotia, disappears beneath walls of water that penetrate hundreds of kilometers inland. Manhattan, with its towering skyscrapers reaching heights of over 400 meters, vanishes completely beneath the surge. The Appalachian Mountains, rising to elevations exceeding 2,000 meters, create the first significant barrier to the inland penetration of these waters, but not before the tsunami has completely inundated an area encompassing over 1 million square kilometers. Across the Atlantic, the European coastline experiences similar devastation. The English Channel, already severely disrupted by the earlier tidal surges, becomes a conduit for waters that surge across the Low Countries and penetrate deep into the heart of continental Europe. Amsterdam, built largely below sea level and protected by an intricate system of dikes and flood barriers, disappears beneath waves that overtop even the highest barriers by hundreds of meters. The Mediterranean Sea, confined by the narrow Strait of Gibraltar, experiences a phenomenon resembling a massive washing machine, as tsunami waves reflect back and forth between Europe, Africa, and Asia. Rome, built on 7 hills rising to elevations of approximately 50 to 60 meters above sea level, finds its ancient foundations submerged as the Mediterranean basin fills with debris-laden water, carrying fragments of lunar material mixed with terrestrial sediment. Meanwhile, the lunar core, still largely intact despite losing its outer layers, continues its approach toward Earth. Now appearing in the sky as a dark, irregularly shaped mass roughly twice the apparent size of the original full moon, it represents a concentration of approximately 14 trillion kilograms of iron, nickel, and rock, compressed into a sphere roughly 480 kilometers in diameter. Earth's magnetic field, generated by the circulation of molten iron in our planet's outer core, begins interacting with the approaching lunar core in unprecedented ways. The moon's core, partially molten and containing vast quantities of iron and nickel, acts like an enormous magnet approaching Earth at cosmic velocities. This interaction creates magnetic field disturbances that disrupt every electromagnetic system on Earth's surface. Satellites in Earth orbit, numbering approximately 4,400 active spacecraft, begin experiencing systematic failures as their electronics succumb to the intense magnetic field fluctuations. The Global Positioning System constellation, consisting of 31 satellites providing navigation services worldwide, goes completely offline. Communication satellites, including the geosynchronous orbit platforms that enable intercontinental telephone and internet communications, cease functioning as their sensitive electronics burn out under the electromagnetic assault. On Earth's surface, power grids spanning continents begin experiencing cascading failures as magnetic field variations induce enormous electrical currents in transmission lines. The North American electrical grid, interconnecting power generation facilities across an area spanning over 20 million square kilometers, experiences current surges exceeding the capacity of every protection system. Transformers explode simultaneously across the continent as electrical currents, thousands of times normal operating levels, flow through conductors designed for much smaller loads. The Hoover Dam, generating approximately 4 billion kilowatt-hours of electricity annually through its 17 turbine generators, suddenly produces electrical output at levels that instantly destroy every connected transmission line. Lake Mead, the reservoir created by the dam and containing approximately 32 cubic kilometers of water, begins draining through the damaged spillways as the facility's control systems fail completely under the electromagnetic chaos. Similar failures cascade across every industrialized region on Earth. The Three Gorges Dam in China, the world's largest hydroelectric facility with an installed capacity of over 22,000 megawatts, experiences catastrophic failure of its 34 turbine generators. The dam itself, stretching 2,335 metres across the Yangtze River and rising 185 metres above the riverbed, holds back approximately 39 cubic kilometres of water in its reservoir. As the lunar core approaches to within 10,000 kilometres of Earth's surface, approximately the altitude of Earth's exosphere, the gravitational effects become indescribable. The core's mass, concentrated into a relatively small volume, creates gravitational accelerations at Earth's surface exceeding normal gravity by factors of 10 or more in the regions directly beneath its approach path. Ocean waters begin literally falling upward toward the approaching lunar core, creating a massive aqueous bulge reaching heights of several thousand meters above normal sea level. The Pacific Ocean, containing approximately 710 million cubic kilometers of water, begins forming a mountain of seawater that follows the lunar core's trajectory across the sky. This aqueous mountain, kilometers in height and hundreds of kilometers in diameter, moves across the Pacific at speeds determined by the lunar core's orbital velocity. As this impossible mountain of seawater approaches the western coast of North America, coastal ranges that have stood for millions of years prepare to experience forces beyond geological comprehension. The Cascade Range, stretching from northern California to British Columbia, and including volcanic peaks like Mount Rainier and Mount Shasta, sits directly in the path of this approaching wall of water whose mass exceeds that of all terrestrial mountains combined. The lunar core, now close enough that its gravitational field varies noticeably across Earth's diameter, begins creating differential forces that exceed Earth's structural limits. Our planet, with its diameter of 12,742 kilometers, experiences gravitational acceleration that differs by over 50% between the side facing the lunar core and the opposite hemisphere. Earth's mantle, composed of approximately 4 trillion kilograms of semi-molten rock at temperatures exceeding 1,000 degrees Celsius, begins responding to these differential forces like a fluid. Volcanic activity explodes across every tectonic boundary as the mantle circulation patterns, stable for millions of years, suddenly reverse and accelerate under the lunar core's gravitational influence. The Mid-Atlantic Ridge, an underwater mountain range stretching approximately 10,000 kilometers from the Arctic to the southern Atlantic Ocean, becomes a continuous line of volcanic eruptions as the seafloor spreading rate accelerates from its normal 2 centimeters per year to several meters per hour. Magma fountains breach the ocean's surface, creating new islands and filling the Atlantic basin with volcanic debris and superheated steam. Iceland, city directly atop the Mid-Atlantic Ridge, experiences volcanism that makes the island's historically active systems appear dormant by comparison. The Vatnajökull ice cap, covering approximately 8,000 square kilometers with ice averaging 400 meters in thickness, disappears within hours as the underlying volcanic systems heat the bedrock to temperatures exceeding the melting point of granite. The Hawaiian island chain, formed by volcanic activity over a mantle hotspot, experiences simultaneous eruptions from every volcanic system across all islands. Mauna Loa, the world's largest active volcano with a volume of approximately 75,000 cubic kilometers, begins erupting at rates that empty its entire magma chamber within hours rather than the decades typically required for major eruptions. As the lunar core approaches to within 5,000 kilometers of Earth's surface, atmospheric effects begin that transform our planet's appearance from space. Earth's atmosphere, normally extending to an altitude of approximately 10,000 kilometers before transitioning to space, begins streaming away toward the approaching lunar core like a cosmic wind. The thermosphere and exosphere, normally containing extremely thin concentrations of atmospheric gases, become dense enough to glow visibly as atmospheric particles accelerate toward the lunar core at speeds exceeding escape velocity. Aurora display is typically confined to polar regions where Earth's magnetic field channel solar particles now appear across the entire sky as the disrupted magnetic field allows cosmic radiation to penetrate everywhere in Earth's atmosphere. Oxygen and nitrogen, the primary constituents of Earth's atmosphere representing approximately 21% and 78% of atmospheric composition respectively, begin separating as their different molecular weights respond differently to the lunar core's gravitational field. The result creates atmospheric layers of varying composition that scatter light in unprecedented ways, painting the sky in colours that have never appeared in Earth's 4.5 billion year history. Aircraft still remaining airborne, including military jets capable of operating at altitudes exceeding 20,000 metres, experience flight conditions that render conventional aerodynamics meaningless. The varying atmospheric density, changing by factors of 10 over distances of just kilometres, creates turbulence that no aircraft design has ever contemplated. Commercial airliners, with their service ceilings typically limited to approximately 13,000 metres, find themselves either forced to emergency landings by impossible flying conditions or simply torn apart by atmospheric forces beyond their structural limits. The International Space Station, orbiting Earth at an altitude of approximately 410 kilometres at a velocity of 7.66 kilometres per second, faces impossible orbital dynamics as the approaching lunar core's gravitational field overwhelms Earth's gravitational binding. The space station, with its mass of approximately 420 tons and dimensions spanning 108 metres across its solar array wingspan, cannot maintain stable orbital parameters as gravitational forces shift unpredictably. Astronauts aboard the station witness views of Earth that no human has ever seen. The planet below appears to be consuming its own atmosphere as massive columns of air stream upward toward the approaching lunar core. City lights, normally visible as scattered points across the darkened continents, flicker and disappear as power grids fail, and urban areas succumb to the unprecedented forces reshaping Earth's surface. The lunar core, now close enough that its surface features would be visible to the naked eye if it weren't silhouetted against the cosmic background, represents the final moments before impact. Radio communications worldwide have ceased entirely as the ionosphere, normally reflecting radio waves back to Earth's surface, disperses into space. The last functioning emergency broadcasts transmitted from facilities with independent power systems and hardened electronics describe scenes that sound more like science fiction than reality. Reports stream in from every continent describing phenomena that challenge human comprehension. In Australia, Uluru, the massive sandstone monolith rising 348 metres above the surrounding desert, begins visibly tilting as the ground beneath it flexes under tidal forces exceeding anything in Earth's geological record. The rock formation, approximately 3.6 kilometres long and 1.9 kilometres wide, represents approximately 1 billion tonnes of sandstone that have remained stable for over 550 million years. In Africa, Victoria Falls, where the Zambezi River plunges 108 metres over a width of 1,708 metres, reverses direction entirely as the river water falls upward toward the approaching lunar core. The mist that normally rises from the falls, visible from distances exceeding 20 kilometres, and giving the falls their local name Mosioatunya, meaning the smoke that thunders, now streams skyward in defiance of every natural law that has governed Earth's hydrology for billions of years. Mount Everest, standing 8,848 metres above sea level as Earth's highest peak, experiences phenomena that would be impossible under normal gravitational conditions. Snow and ice, representing millions of tons of frozen water accumulated over millennia, begins sliding upward along the mountain slopes toward the approaching lunar core. The jet stream winds that normally flow around the peak at speeds exceeding 200 kilometers per hour suddenly reverse direction and accelerate to supersonic velocities. The Dead Sea, lying 434 meters below sea level and representing the lowest elevation on Earth's land surface, becomes a bizarre spectacle as its dense, salt-laden waters begin forming impossible waterspouts that spiral upward for kilometers. The sea's salinity, approximately 34% compared to typical ocean water salinity of 3.5%, creates gravitational effects that differ noticeably from normal water, as the heavier brine responds more strongly to the lunar core's gravitational pull. In the Amazon basin, trees that have grown for centuries in the dense rainforest canopy begin experiencing gravitational forces that exceed their structural limits. Cecropia trees, adapted to rapid growth in the rainforest understory and reaching heights of 25 meters, cannot withstand the variable gravitational fields and begin falling in patterns that create clearings visible from orbital altitude. The forest canopy, normally so dense that less than 2% of sunlight reaches the forest floor, opens into geometric patterns as trees fall in directions determined by the constantly changing gravitational field. As the final minutes approach before impact, the lunar core, now filling approximately 30 degrees of the visible sky and appearing as a dark sphere roughly 60 times larger than the original full moon, begins interacting directly with Earth's solid surface. Mountains begin visibly deforming as differential gravitational forces exceed the compressive strength of granite and basalt. The Rocky Mountains, stretching approximately 4,800 kilometers from New Mexico to British Columbia, experience compression forces that fold sedimentary layers like accordion pleats. The Himalayas, formed by the collision between the Indian and Eurasian tectonic plates over the past 50 million years, begin experiencing forces that dwarf the original mountain-building processes. K2, the world's second highest peak at 8,611 meters above sea level, starts collapsing as the gravitational field gradient across its height exceeds the structural limits of the metamorphic rock forming its summit pyramid. Ocean floors begin buckling upward as the approaching lunar core's gravitational field creates pressure differentials that overcome the weight of overlying seawater. The Mariana Trench, plunging to depths exceeding 11,000 meters below sea level, begins collapsing as the surrounding seafloor rises under gravitational forces that make the overlying water column effectively weightless. In the final moments before impact, as the lunar core approaches to within 1,000 kilometers of Earth's surface, the distinction between Earth's atmosphere and space disappears entirely. Atmospheric gases stream away from Earth at velocities exceeding escape velocity, creating a comet-like tail of terrestrial atmosphere extending millions of kilometers into space behind our planet. The impact itself, when it finally occurs, represents the release of energy equivalent to approximately 100 million times the energy that created the Chicxulub crater 66 million years ago. That ancient impact, which contributed to the extinction of the dinosaurs, released energy equivalent to approximately 100 million megatons of TNT. The lunar core impact exceeds this by 8 orders of magnitude, representing energy equivalent to 10 quadrillion megatons of TNT. The impact site, whether it occurs on land or sea, instantly becomes a crater measuring approximately 1,000 kilometers in diameter and reaching depths that penetrate through Earth's crust into the upper mantle. The shockwave travelling outward from the impact point moves faster than seismic waves, reaching the antipodal point on Earth's surface in less than 20 minutes, and focusing seismic energy that liquefies solid rock across areas spanning entire continents. If the impact occurs in the Pacific Ocean, the resulting crater would encompass an area roughly equivalent to the combined territories of France, Germany and Spain. The displaced seawater, launched into ballistic trajectories at velocities exceeding escape velocity, would rain back down across the entire planet as steam and ice crystals, fundamentally altering Earth's hydrological cycle for millions of years. The thermal effects of the impact would raise global atmospheric temperatures by hundreds of degrees Celsius within hours, vaporizing surface water and creating atmospheric conditions that would prevent liquid water from existing anywhere on Earth's surface for thousands of years. The impact debris, launched into Earth orbit and beyond, would create a ring system around Earth resembling Saturn's rings, but composed of terrestrial and lunar material mixed together. This scenario, while physically impossible under current astronomical conditions, since the Moon is actually gradually moving away from Earth at a rate of approximately 3.8 centimeters per year, demonstrates the incredible forces that govern celestial mechanics and the delicate balance that allows life to exist on our planet. The Moon's current stable orbit, maintained for billions of years, provides the gravitational stability that helped enable the development of complex life on Earth by moderating our planet's axial tilt and creating the predictable tidal cycles that may have facilitated the transition of life from ocean to land. Understanding the catastrophic consequences of such an impossible scenario helps us appreciate the remarkable stability of our cosmic neighborhood and the intricate gravitational dance that has allowed human civilization to develop and thrive. The Moon, our constant companion throughout human history, continues its slow spiral away from Earth, ensuring that this nightmare scenario remains forever in the realm of thought experiment rather than physical possibility. The detailed exploration of this scenario reveals the interconnected nature of Earth's systems, from the deepest ocean trenches to the highest mountain peaks, from the planet's molten core to the edge of space itself, all working together in a delicate balance that sustains the only known haven for life in the universe.